Okay, so these are the last two examples that I didn't get a chance to finish in class today, or yesterday. Today, yeah. So SAT scores have a mean of 500 and a standard deviation of 100. The difference in this is that this is quantitative data. We can actually get a score, and that's why they're telling us that the mean is 500 and what the standard deviation is. Okay, so think. What do we want? We want the distribution of possible means from samples of SAT scores from these 20 students. Okay, distribution, I know this isn't going to fit in here. Distribution of possible means from the sample of SAT scores of 20 students. Okay, all right, let's go through what the conditions are. Okay, and we have, they are randomly selected. It says that in the problem, mean of random samples. So you would write that out. So I'm not gonna write these out, but you make a list of these. Okay, 10%, 20 is less than 10% of all students who are at this school. Okay, and independence, they are mutually independent. They're not from the, we're going to assume that they're not from the same university. Okay, so if at this point, if I'm talking too fast, you need to pause and rewind and make sure you write all of those down. Get in the habit of always looking at those. Okay, all right, so what do we know right now? Well, we know that the mean in this case, we'll do it this way. The mean in this case is 500, and the standard deviation that they give us is 100. Okay. So we need to first calculate what the standard deviation is given this mean, given this sample. Okay. So the sample here is going to be the standard deviation over the square root of n. The reason I'm writing it this way is so that we know we're finding the standard deviation of the sample, not of the whole thing. Okay. So this is equal to 100 divided by the square root of 20, and you get 22.36. Okay, excuse me. So on our normal model, the mean is 500. The standard deviation is 22.36. 1, 2, 3 standard deviations. This is exactly the same. None of that is different. Okay. And all we're doing is we're finding the distribution. I'm not going to go through all of it because I think you get the idea from what we already did before. Okay, so here's how we want to write this. According to the normal model, we can expect 68% of samples of 20 students to have a mean SAT scores between 477.6 and 522.4. I'm going to write etc. here because you would continue to figure this out. So where did these numbers come from? You might be asking that. Well, I took 500 and I subtracted this standard deviation once. I would subtract it again to get this. So this is minus 1 standard deviation, minus 2 standard deviation, minus 3 standard deviation. Keep subtracting to get all of those. Okay? All right. So next one, here's another example. Okay. At birth, babies weigh 7.8 pounds. Standard deviation is 2.1 pounds. Okay, so here's my mu is 7.8 pounds. My standard deviation is 2.1 pounds. Random sample of 34 babies born to mothers living near a large factory that may be polluting the air shows a birth weight of 7.2 pounds. Is that unusually low? Is what we want to compare this to. All right, so what do we want is we're going to find out what the distribution is and then decide if 7.2 is outside of, you know, 1 or 2 standard deviations, and then that's something that's unusual. Okay, so that's the think. Random sampling condition, well, we're going to, they are randomly selected. They do happen to live near this large factory, but they are just, they say right here, it's a random sample. 10%, 34 babies is going to be, we're going to make the assumption that that is less than 10% of the population of all the people who live there, of those mothers, okay? So we need a z-score because we have to find out if this weight is unusually low. All right, so the first thing we're going to do is find the standard deviation. So standard deviation of y is 2.1 over the square root of 34 equals 0.36 pounds. Okay, now we need to know what the z-score is. So z, we're going to compare the y, this y bar minus mu over the standard deviation of of just this sample. Okay, so in this sample, 7.2 pounds is what it comes out to, minus 7.8, because that's the mean that we expect to see, over 0.36. My z-score is negative 1.67. Okay, so on the normal curve, get in the habit of drawing this too. Here's my mean of 7.8. Here is 7.2. So we want to know, is this out of the ordinary? Okay, so right in here, if we figured out, use normal CDF, what the probability is with negative 1.67, we get that it's 4.7%. Okay, it's almost 2 standard deviations away. I would say that is unusual. So your conclusion, your tell would be, that does seem out of the ordinary. Is only a 4.7, or there's a 4.7% probability that the babies would be that size. So it could be because of the large factory. And then I would end it with more research should be done, gathering more samples to determine if the factory is having an effect. Okay, so something along those lines. This right now is what is most important, that we get the math down, and we'll keep working on the conclusions. Okay, so 4.7% is your final answer. Okay, all right, that's it with this video.